Hello friends, I am Snehal and I am teaching you physics. In today's lecture, we will see some problems on vector addition and vector multiplication. So let us start. So our first problem is find the vector which when added to a bar equals to 3i minus 2j plus 5k and b bar equals to, let's take minus 4i plus 9k gives a unit vector parallel to z-axis. So we have to find a vector which when added to this a bar and b bar will give us unit vector along z-axis. So suppose c bar is the required vector So according to this condition given in the problem, according to given condition, I can write that a bar plus b bar plus this required c bar will give me unit vector along z-axis. So a bar plus b bar plus c bar equals to k cap. So this is very simple. What will be c bar then? So c bar equals to k cap minus, we'll take this a bar and b bar on other side, so it becomes minus of a bar plus b bar. Now we have to just plug in the values of a bar and b bar. So let's substitute. So a bar is 3i minus 2j plus 5k. And what's b bar? So it is minus 4i plus 9k. So let us solve this. So 3i minus 4i will be minus I. So it is minus I. Then minus 2j. And there is no j here. So it is minus 2j only. Plus 5k and plus 9k, so it is 14k, it is plus 14k. Now this negative sign, so it becomes I plus 2j and k minus 14k, so which is minus 13k. Check my algebra. So if everything is fine, then this is the answer. Very simple. Let us see problem number 2. Another simple problem. So problem number 2. Two vectors have magnitudes 4 unit and 5 unit respectively, and angle between them is, let's take 60 degrees. Find their resultant. Okay, so another simple problem. Two vectors have magnitudes 4 units and 5 units respectively. Angle between them is 60 degrees. Find out their resultant. So let's take two vectors. So suppose a bar and b bar are the two vectors and C bar equals to A bar plus B bar. Theta equals to 60 degrees. This is all given. So what will be magnitude? We know C equals to square root of A square plus B square plus 2 times A into B into cosine of theta. Okay, so this is parallelogram law. Resultant magnitude is equal to square root of magnitude squared of first vector, magnitude squared of second vector, plus 2 times the magnitude of first into magnitude of second vector multiplied by the cosine of angle between two vectors. Now we just have to plug in the values 4 and 5. So 4 square plus 5 squared plus 2 times 4 into 5 multiplied by cosine of 60, and cosine of 60 is 1 by 2. So this cosine of 60, which is half, and this 2 gets cancelled. So we have 20 from there. 16 plus 5 squared is 25 plus 20 from that last term. So it is 45 plus 16. So which I guess is 61. Square root of 61 units. Now let's see another simple problem. So problem number 3 is this A bar equals to 2i plus 3j minus 4k, and B bar is 4i plus mj minus 8k. They are parallel to each other and we have to find m. Okay, so m is unknown and a condition is given that they are parallel. We have to find m. So how to proceed? It's very simple, that we know that if two vectors are parallel to each other, then ratio of their components is same. Okay, so what should I get is ax by bx equals to ay divided by by. It is az divided by bz, and it is a constant. So let's find ax by bx, or we have to use only this. Let's take ay by by equals to ax by bx. Now let's substitute the values. So ax is 2, bx is 4. So this is equal to 2 divided by 4. Ay is 3 and by is m, which we have to find. So m, this is 1 by 2. So if we multiply this out, then we get m equals to 3 2s are 6. So it's very, very simple. Now I will change the condition in this problem, and let's see problem number 4 now. A bar equals to this, B bar equals to this, are perpendicular to each other. Now find the m. Okay, so it should be very simple. We know how to check whether two vectors are perpendicular or not. Okay, so two vectors are perpendicular if their dot product is 0. We know this from last lecture. Okay, so what can I write is a bar dot b bar is equal to 0. Let's substitute the values of a bar and b bar. So it is 2i plus 3j minus 4k multiplied by 4i plus mj minus 8k, and this should give me 0. Then it is ax bx, which is 8, plus ay by, which is 3m, or m times 3, so 3m, minus, and that minus, plus 8 4s are 32, it is 32, is equal to 0. Okay, so 32 plus 8 is 40, we'll take it on other side, it becomes minus 40, so 3m equals to minus 40, and which gives me m equals to minus 40 divided by 3. Okay, so in this problem we have seen that if two vectors are parallel, then we'll check the ratio of their components and then find the unknowns, and if condition given is two vectors are perpendicular, then obviously the scalar product of two vectors will be 0. Okay, now let us see problem number 5, and problem number 5 is find area of a triangle whose two sides are given by these two vectors, a bar equals to 2i plus 3j minus k cap, and b bar equals to 3i plus 2k cap. Okay, so how do we solve this? Recall from the last lecture that if we have these two vectors a bar and b bar given by two sides of parallelogram, then area of parallelogram equals to magnitude of vector product of a bar and b bar. Okay, and area of triangle is just half of area of this parallelogram. So this is the area of triangle. So area of triangle whose two sides are represented by two vectors is equal to half of magnitude of vector product of the two vectors. Okay, so let's do it. So let's find c bar, which is equal to a bar cross b bar. So we know how to find a bar cross b bar. It is determinant of I, j, k, then ax, ay, az, and bx, by, bz. The third row. Let's substitute these values. So ax is 2, ay is 3, and az is minus 1. Let's substitute that. It is I, j, k. Ax is 2, 3, minus 1, and bx is 2. There is no by here, no coefficient for j cap, and bz is 2. So 3, 0, 2. Okay. Then we know how to solve determinants. So it is I multiplied by 3 into 2 minus 0 into minus 1, which is 0 basically. So 3 2s are 6 minus 0, minus j cap times hide this row, this column. So we have 2 into 2 minus this 3 into minus 1. So 2 2s are 4 minus 3 1s are 3 with this negative sign, so which makes this positive, so 3. Then we have plus k cap into this, 2 zeros are 0 minus 3 3s are 9, so 0 minus 9. So let us rewrite this. We have 6i minus 7j minus 9k. So this is c bar. Okay, and the area of triangle equals to half of magnitude of a bar cross b bar, that is half of magnitude of c bar, because a bar cross b bar is c bar, so it is equal to area of triangle equals to half of magnitude of c bar, which is half of square root of cx square plus cy square plus cz square. That is equal to half of cx square is 6 square plus cy square is minus 7 square plus cz square is minus 9 square is equal to half of this is 36 plus 49 plus 9 square is 81. So 81 plus 49 will give me 130. 130 plus 36 is 166. It is square root of 166 divided by 2. And because its area, it will be in square units. Okay, so area of triangle will be this. Now let me change this problem. So we'll see problem number 6, and we'll take same a bar and b bar. So question is now find unit vector perpendicular to plane of vectors a bar and b bar. Okay, so now we have a bar, which is this, b bar, which is this, and we have to find unit vector which will be perpendicular to a bar as well as b bar. So how do we find it? Recall from last lecture that a unit vector or a vector perpendicular to plane of two vectors is given by cross product of two vectors, which we have already found. So this is a vector perpendicular to plane of a bar and b bar. Then question is to find unit vector. Now recall, how do we find unit vectors? So I can have unit vector c cap will be equal to c bar divided by magnitude of c bar. This is how we find unit vectors. And we found magnitude of c bar, which is this, square root of cx square plus cy square plus cz square, and which we found as square root of 166. So we just have to substitute these values here. So let me do that. So it is 1 divided by square root of 166. I have taken this magnitude of c bar, square root of 166 here, multiplied by the 6i minus 7j minus 9k. So this is c cap, the unit vector which is perpendicular to a bar as well as b bar. Okay, now let's see last problem for the lecture, and it is find the angle between two vectors a bar equals to, let's take 2i minus 2j plus 5k, and b bar equals to, or let me just take a bar equals to 2i minus 2j and b bar equals to 5k or 5i cap. Okay, so let's try it. Now we know how to find an angle between vectors. We know that dot product is given by a bar dot b bar equals to magnitude of A into magnitude of B multiplied by cosine of the angle between vectors, and therefore cosine of theta equals to A bar dot B bar divided by this magnitude of A into magnitude of B. Now let us find magnitudes of A bar and B bar, and also this A bar dot B bar. So A bar dot B bar equals to 2i minus 2j dotted with this 5i. So 2i times 5i gives me 10. I times I is 1, and then there is nothing in the second vector as coefficient of j, so we have only 10. A dot B is 10. Then magnitude of A, the square root of ax square plus ay square plus az square, which is 2 square plus minus 2 square, and there is no az, so that's it. So 2 square is 4, minus 2 square is 4, so it is square root of 8. Then magnitude of B, it should be clear that it has only one component, so magnitude of B is 5. So magnitude of B is 5 units. 5 units. Then now let's substitute this A bar dot B bar, magnitude of A and magnitude of B, in this equation. So we have cosine of theta equals to this. So A bar dot B bar is 10 divided by square root of 8 multiplied by magnitude of B is 5. 10 divided by 5 is 2, and we have 2 divided by square root of 8, which is 4 times this 2. So square root of 4 is 2, which gets cancelled with this 2 in numerator, so we have 1 divided by root 2. So cosine of theta equals to 1 divided by root 2. Now the angle theta will be cosine inverse of 1 divided by root 2, and we know that cos of 45 gives me 1 divided by root 2, so this theta should be equal to 45 degrees. Now we are quite familiar with the concept of vectors. In next lecture, we will see motion in a plane. Till then, try some problems on vector addition and vector multiplication. Thanks for watching the lecture.